Hello and welcome to our chemistry lessons today. I'm your regular host, Mr. Philip Mamman. Previously on our chemistry lessons, we did discuss the concept of atoms, ions, and molecules. And during our course of discussion, we discussed the concept of atomic number and atomic mass. And we say atomic number is the total number of protons only in an atom. And we said atomic mass is the total number of protons and neutrons in that atom. Today we'll be moving further to look at the concept of relative atomic mass, relative molecular mass, and the mole concept. Now, ordinarily, one will say that if we have the total number of proton and neutron, we know the atomic mass of an atom. But some atoms exist as isotopes. In this case, they have the same atomic number, but different atomic mass. And of course, they exist in different relative abundance in the atmosphere. That is why there is a need for us to learn how to calculate the relative atomic mass of such isotopic mixture. Follow me gradually in today's lesson. You will learn how to define this concept and how to calculate them at different stages. Now let's start by the definition of atomic mass. We say atomic mass is the atomic mass of an element is the number of times one atom of that element is as heavy as 1 over 12 the mass of one atom of carbon 12 isotope. Again, the atomic mass of an element is the number of times one atom of that element is as heavy as 1 over 12 the mass of one atom of carbon 12. If you look at some other textbooks, they will tell you that the atomic mass of an element is the mass of that element on a scale where carbon 12 weighs 12 units. It means that if you pick that atom and put it on the same scale where carbon 12 has the mass of 12 units, it will give you the atomic mass of that element. Now, atomic mass has a unit of atomic mass unit. AMU. Again, atomic mass has a unit of atomic mass unit, AMU. Sometimes it is also measured in grams. Now, what is relative atomic mass? Now, the relative atomic mass of an element is the number of times the average mass of one atom of the element is heavier than 1/12 of the mass of one atom of carbon 12. Again, the relative atomic mass of an element is the number of times the average mass of one atom of the element is heavier than 1/12 of the mass of one atom of carbon 12. Now, atomic mass and relative atomic mass are similar. Of course, because they are dealing with the same substance. But then, relative atomic mass is a comparison. And by so doing, we have what we refer to as is more like a ratio, so that we can say that relative atomic mass does not have a unit. So the basic difference between atomic mass and relative atomic mass is that atomic mass has a unit of AMU, atomic mass unit, while relative atomic mass does not have a unit. So in the same vein, we'll be looking at relative molecular mass. When we say relative molecular mass or molecular mass, is another form of what we refer to as molar mass. So anytime you hear a chemistry teacher or a chemist say molar mass, we're talking about relative or molecular mass. Molecular mass is the same as molar mass. So we say the molecular mass of a substance is the number of times one molecule of that substance is as heavy as carbon 12 of carbon 12 atom. 1 over 12 of carbon 12 isotope. In other words, we say the relative molecular mass of a substance is the mass of that substance on a scale where carbon 12 weighs 12 units. Whatever way you think is easier for you to define this concept, these two definitions or more are acceptable by authority. So let's look at this relative atomic mass. Now, to calculate the relative atomic mass of an isotopic mixture, remember I told you that they have difference in relative abundance. So to calculate the relative atomic mass of an element, the relative abundance of the isotopic mixture must be considered. For instance, or for example, we say chlorine exists in an isotopic mixture as chlorine 35 and chlorine 37. Remember, both chlorine 35 and chlorine 37 have atomic number of 17 each. So relative abundance of 75 and 25 respectively. This means that chlorine 35 has relative abundance of 75, while chlorine 37 have relative abundance of 25. So to calculate the relative atomic mass of chlorine atom, we use this formula. Relative atomic mass of chlorine is equals to percentage abundance of chlorine 35 times atomic mass of chlorine 35. Of course, the atomic mass of chlorine 35 is 35 plus percentage abundance of chlorine 37 times atomic mass of chlorine 37. Now, the atomic mass of chlorine 37 is 37. So if you do this arithmetic, you realize that relative atomic mass of chlorine is equal to 75 over 100 times 35 plus 25 over 100 times 37. If you evaluate this, you have 26.25 plus 9.25. So if you sum 26.25 plus 9.25, we get 35.5, which is the relative atomic mass of chlorine. So anytime you come across chlorine and you see 35.5 as relative atomic mass of chlorine, you know that this is how it was resolved. Now, alternatively, we have an alternative method. The first thing to do is to find the ratio of the percentage abundance. Remember, we say it's 75 and 25. And when you're looking for a ratio, you divide through by the lowest number. Between 75 and 25, of course, 25 is the lowest. So we say 75 over 25 and 25 over 25. You get a ratio of 3:1. Now, once you have gotten the ratio of 3:1, then you multiply the atomic mass by the ratio as 35 is times 3, which gives us 105. Then 37 is times 1, which gives us 37. Now, if you sum up these two, 105 and 37, you will get for 142. And if you sum up the ratios of 3 plus 1, you will get 4. So you are going to add up 105 and 37 to get 142. And we have 3 plus 1 to give you 4. So divide the sum 142 by the sum of the ratio, which is what? 4. So we say 142 divided by 4, it will give us 35.5. Now, whatever method you choose to apply, you still arrive at the same answer. Of course, I encourage you learners to use the most convenient method, the method you understand more. It will be easier for you to remember, and you'll be able to resolve any other question that is related to this topic. So let's move further to see how to calculate the relative molecular mass. Now, relative molecular mass is usually the sum of the atomic masses of all the atoms in that molecule. For instance, we say calculate the relative molecular mass of lead-2 trioxonitrate 5. Again, lead-2 trioxonitrate 5. Calculate the relative molecular mass of lead-2 trioxonitrate 5. So the atomic mass of lead is 108, that of nitrogen is 14, and oxygen is 16. So to find the relative molecular mass of this molecule, we will say mass of lead times 1 plus mass of nitrogen times 2 plus mass of oxygen times 6. Now, how do we get the mass of lead times 1? Because there's only one lead in the formula. How do we get the mass of nitrogen times 2? Because there are 2 nitrogens. Look at the 2 outside this bracket. If you multiply it by the n, nitrogen, here you have n times 2. Then plus oxygen is 3 in the bracket. Multiply by the 2 outside the bracket, it becomes 6. So we have 108 plus, open bracket, 14 times 2, close bracket, plus 16 times 6. And when you do this arithmetic, you arrive at 184. Remember, it's relative at molecular mass, so it does not have a unit. In the same vein, another example says calculate the relative molecular mass of tetraoxosulfate 6 acid. Now, look at this. In this case, we say molar mass of tetraoxosulfate 6 acid is hydrogen times 2 plus sulfur times 1 plus oxygen times 4 equal to 1 times 2, which is the atomic mass of hydrogen. Atomic mass of hydrogen is 1. Then plus 32 times 1, atomic mass of sulfur is 32, plus 16 times 4, atomic mass of oxygen is 16. Now, if you resolve this, you arrive at 98 grams per mole. Remember, this is molecular mass. Molecular mass has a unit of gram per mole, while relative molecular mass does not have a unit. Another example is calculate the relative molecular mass of carbon 4 oxide. Carbon 4 oxide is CO2. So that we say relative molecular mass is equals to mass of carbon times 1 plus atomic mass of oxygen times 2, which will give us 12 times 1. 12 is the atomic mass of carbon. 16 times 2. 16 is the atomic mass of oxygen. When you sum up this in this arithmetic, you have 44. My wonderful learners, it's high time you practice other options. You can bring out formulas of different compounds and find their relative molecular mass or molecular mass as the case might be. Another name for molecular mass, apart from molar mass, is also called formula mass because the mass is usually calculated from the formula. So it is ideal that you get the correct formula of the compound, which correspondingly you can work on to get the correct formula of the molecule. As we move further, we'll be looking at the mole concept. What is mole? And most at times in chemistry, we hear mole, mole, mole. Today, we'll be looking at what a mole is. Now, a mole of a substance is the amount of that substance that contains as many elementary particles. These particles such as atoms, molecules, ions, electrons, etc. as there are atoms in 12 grams of carbon-12. Now, the number of mole is equals to mass over molar mass or mass over atomic mass. Now, if it is a molecule, it's mass over molecular mass or mass over molar mass. If it is an atom, it's mass over atomic mass or relative atomic mass, as the case might be. Example, calculate the number of moles in 6 grams of carbon. Now, carbon is an atom, so we are going to use the relative atomic mass of carbon, which is 12. Therefore, we say number of moles of carbon is equals to 6 all over 12, which is equals to 0.5. Another example again is calculate the number of moles of 4 grams of oxygen in oxygen molecule. Remember here we are talking about oxygen molecule. So the formula for oxygen molecule is O2. So molar mass of oxygen molecule is the same thing as saying 16, which is the atomic mass of 1 oxygen, multiply by 2 to give you 32. Now, when you say molecular mass, it's going to be what? 32 grams per mole. Remember that number of mole therefore is equals to 4 divided by 32, where 4 is the mass and 32 is the atomic mass or relative atomic mass, and that will give you 0.25 moles. Again, 0.25 moles. You can go over this over and over and over until you get the concept clearly. Remember, a mole of a substance is the amount of that substance containing as many elementary particles. Such particles are atoms, molecules, ions, electrons, etc. as there are in atoms in 12 grams of carbon-12. You remember I said number of mole is equals to mass over molar mass or mass over relative atomic mass, depending on whether it's a molecule or as is an atom. Another definition of a mole is that a mole is the amount of a substance that contains as many elementary entities. These elementary entities are what we refer to as particles, as there are in carbon-12. Remember this definition because it will come handy when you need it in an examination. Now let's move further to say, now the concept of Avogadro's number, another word is Avogadro's constant. You can call it Avogadro's number or Avogadro's constant. Now, a mole of a substance is the amount of that substance containing as many elementary particles. Remember I said those particles are atoms, molecules, ions, or electrons, as there are in carbon-12 or in 12 grams of carbon-12. The atomic mass of a molecule or molar mass, molecular mass of any substance is the mass of that substance containing 6.02 times 10 raised to the power 23 particles of that substance. Remember, 6.02 times 10 raised to the power 23 is called Avogadro's number or Avogadro's constant. In other words, we'll say a mole of a substance is the amount of that substance that contains as many elementary particles as there are in 6.02 times 10 raised to the power 23. Now, this 6.02 2 times 10 raised to the power 23 is known as Avogadro's constant. Note that 6.02 times 10 raised to the power 23 is the Avogadro's constant. It's a constant you should remember all the time because you need to use it in many of your calculations. Now let's look at how to apply this formula. Example, how many atoms of neon are there in 10 grams of neon? Remember, 10 grams is the mass of neon, and neon has atomic mass of 20. So number of moles of neon is equals to mass over atomic mass. When you substitute that value, we have 10 as the mass in grams over atomic mass, which is 20, and that gives you 0.5 mole. So the number of mole is also number of particles, which is atoms in this case, all over Avogadro's constant. Remember, Avogadro's constant is 6.02 times 10 raised to the power 23. Now, if we say 0.5 moles, which is the number of moles as we have calculated earlier, is equal to number of atoms all over 6.02 times 10 raised to the power 23. We are not far from it. Now, if you make number of atoms subject of the formula, we say therefore number of atoms is equal to 0.50 times 6.02 times 10 raised to the power 23, which will give you 3.01 times 10 raised to the power 23 atoms. Again, 0.50 times 6.02 times 10 raised to the power 23 will give you 3.01 times 10 raised to the power 23 atoms. My wonderful learners, you have this at the tip of your fingers. You can go over it over and over again until you get the concept clear. Let's take another example. How many molecules are there in 25 grams of calcium trioxocarbonate 4? It's important that you know the formula of calcium trioxocarbonate 4 as it is described here, CaCO3. Now, if you calculate the molar mass, you find out that calcium has atomic mass of 20, carbon has atomic mass of 12, oxygen has atomic mass of 16. So if you calculate the molar mass, you have calcium times 1 plus carbon times 1 plus oxygen times 3, meaning that 40 for calcium, 40 for calcium, 12 for carbon, and 16 times 3 for oxygen. So if you resolve all of this, arithmetically you get 100. So we say number of mole is equals to mass over molar mass, meaning that the mass is 25 grams divided by molar mass of 100. So it will give you 0.25 moles. Now, number of mole is equals to number of particles. Number of particles in this case is molecules, so over Avogadro's constant. Remember, Avogadro's constant is 6.02 times 10 raised to the power 23. So we say number of mole as we got from this stage as 0.25 is equal to number of molecules all over 6.02 times 10 raised to the power 23. Therefore, number of molecule, making number of molecule the subject of formula, is equal to 0.25 times 10 raised to the power times 0.25 times 6.02 times 10 raised to the power 23. If you resolve this arithmetically again, we say 0.25 times 6.02 times 10 raised to the power 23, it will give you 1.505 times 10 raised to the power 23 molecules. 1.505 times 10 raised to the power 23 molecules. Now this value, this here is molecules because you are calculating the number of molecules. Thank you, my wonderful student. It has been an exciting moment with you. Quickly, I would like you to remember that we did define what atomic mass is. We say atomic mass of an element is the mass of that element on a scale where carbon-12 have 12 units. And we also said that the molecular mass of an element is the mass of one molecule of that element on a scale where carbon-12 have 12 units. Remember, of course, that you can apply this and many other methods I have taught you here to resolve your problems. If you have any questions, you can always get back to me. Remember, my phone number is 080-2659-8861. I wish to meet you again in another series of our discussion. But for now, I'll say bye-bye. Have a pleasant day and God bless you.